I think I just turned it off. There we go. There we go. Oh, we'll get there. We don't have to start the live streaming just yet. Or...
Oh, no, it started.
Oh, it's already going? Okay. Already going. I was just going to be like, okay, we're mostly familiar faces here tonight. You know, it's that part of summer when kids are going back to school and everybody's getting busy with all that stuff, you know. So I expect sometimes we're going to fall off a little bit, but Trace, Abby, Chad, John, Ross, Troy, Jerry. Is that right? Yep. What's your last name, Jerry? Yes, yeah. You just should have got the emails from me, right? Did you see that?
No, I didn't get anything yet.
You didn't get anything yet? Gerald, right? G-E-R, yeah. I'll double check your email address and stuff, because I sent out some welcome stuff in the handbook and all that stuff. To me, Joe. Excellent. Let's go ahead and start with our fabulous guest speaker this evening, Mrs. Amy Northrop.
5 years ago.
Yeah. So, yeah, she is our, what's the title? It used to be, they say, well, I mean, here at the HRPO, they used to say education curator or something.
Oh, it's program specialist.
Program?
That's not why I'm here tonight.
No, yeah, but she is the program specialist here for the HRPO, in case you did not know. And yes, she is one of our local solar system ambassadors. And I'm going to turn it over to Mrs. Amy Northrop.
Okay, well, thank y'all for coming. When Ben asked me to do this, I'm like, what's a mission I want to cover? Europa Clipper. Not mainly in the way of updates, but I still love this little mission. So first up, the target is Europa, which is the second large moon discovered by Galileo, hence the name Galilean moon. And all of these little cracks are part of why it is so fascinating. Possibly twice the liquid amount of water we have on Earth, elements necessary for life, and energy to support an ecosystem. What is this, the galactic lottery? So the mission is going to explore 3 goals. Goal 1 is prove that Europa's oceans exist. These were first suspected with the Galileo mission in 1989 because Jupiter's magnetic field did weird things in the proximity of Europa. And it's like, what is going on here? So they concluded that this meant that some kind of current was going through the moon and something was interacting with Jupiter's magnetic field. This actually intrigued them so much that when the mission was originally supposed to be spread out along all 4 Galilean moons, it spent a total of 12 close orbits around Europa, because they just wanted to know more about that. Basically, their concern, or theory, was that water beneath the surface was causing this disruption. And if Galileo's instruments are proven true, this will indicate twice the amount of liquid water that the Earth has. And this is an object that is a little smaller than our moon. That is a staggering quantity of water for an object this size. Basically, one of the ways we're going to hope to confirm it is measure the tidal flexing of the ice. If it exists, the tide should deform the surface by about 30 meters, or 100 feet. If it's frozen through, the tidal effect of Jupiter and the moons will only move at about a meter or 3 feet. As I like to compare to my students, Jupiter and its moons are constantly playing tug of war with gravity. And they're like, well, how does the moon stay hot? And it's like, well, what happens to your hands when you play tug of war? It gets hot from the friction. That same gravitational friction, so to speak, is occurring inside of Europa and also Io, which is why the poor moon is so volcanic. Okay, any questions on this one? Because I have like a page of notes if you'll have questions. No, I'm not joking.
And you said it was the Galileo
Yes.
mission that was out there, right?
Though some evidence has actually indicated that there was actually a little water plume caught from Europa by one of the Voyager spacecraft. But they look back like years later and they're like, oh, we missed that the first time. It only like 1 pixel, so easy to miss.
Yeah.
Good question.
Yes.
Do any of Jupiter's other moons have an effect on Europa's gravity?
Well, Ganymede, for one, is the largest moon in the solar system. It's bigger than Mercury. And there is a 3-4 resonance. Every time, I'm trying to make sure I have each one on the correct number of orbits. Every 4 Io orbits, Europa goes around twice, and then Ganymede goes around once. So there's this constant tugging, and you also have Callisto zipping around on the outside of the outer track. So you always have Jupiter on one side because these moons are tidally locked, and on the other side you'll have the sibling moons just tug at it occasionally. But it's enough to keep them very, very toasty. I mean, poor Io is constantly erupting, constantly.
What about Jupiter's smaller moons?
They don't have the same resonance, and they're not nearly as large. Because all of the Galilean moons are at least the size of ours. Except for Europa, it's going to be a little smaller, but close enough. And Ganymede is the size of Mercury, or a little bigger than Mercury. And it was actually the discovery of these oceans that led to the drastic decision for Galileo's disposal. When the scientists described it as a victim of its own success, instead of allowing it to continue in a little orbit until it decayed, their decision was crash it into Jupiter. And this has become standard for any mission that visits this area because they don't want to risk any Earth cooties contaminating Europa or any other Galilean moons that might harbor life. So whenever the mission's done, they just kamikaze the probe into Jupiter. It is hilarious and I love it. There is one spacecraft right now called Juno that's like, oh, when are they going to get rid of me? Do I have to? My solar panels won't hold up.
So for the first time in history, Juno in good direction.
The entire mission's name is a joke because she could always see through the clouds he made to hide his mischief. And the mission was to look through the clouds of Jupiter. And there are 3 spacecraft-grade aluminum figurines on board. Juno with a magnifying glass, Galileo with a telescope, and Jupiter with a lightning bolt, because NASA said, why not? Yeah, none of the kids believe me when I tell them that there's Legos in space. Okay, any more questions about the oceans before I move on?
Is this one with the tiger? Is it a tiger that, is this one with the tiger?
There is at least one documented account of a geyser on Europa, but it's not what the moon is most known for. Enceladus of Saturn is the one that's more known for its geysers. That's what made Enceladus famous. Oh, this boring little moon of Saturn, it won't do anything. It's like, wait, what? 5 more orbits, please. Because it was supposed to be a one-off orbit, and then they're like, wait, this moon's active. No, since Galileo, we've been suspecting that Europa is active. We just want to know how active. Like, do we have cousins down there? Are we going to see a scene from James Cameron's Abyss or something? Okay, so step 2 is finding the chemistry. Water isn't the only thing needed for life. We also need things like carbon, hydrogen, phosphorus, oxygen, and sulfur. Those are key things that make up 98% of all living matter on Earth. So the question is, does Europa have the ingredients for this? We know that because of the way the ice moves, that there is some kind of plate tectonics happening within Europa. So we're wondering if the rocky bottom so to speak, of the ocean has volcanic vents that are introducing these materials into the ocean. We know, based on the fact that, one, there's a magnetic flux loop connecting Io to Europa occasionally, that the moon is getting sulfur, even if it's not producing it itself, because the cracks that were on those images allow liquid and materials to get into the water. They refreeze quickly, but how much do you need? They're also wondering if these things are actually included in Europa's shell, and whether or not there is an exchange of materials between the icy shell and the ocean. We know that there's a thin exosphere of oxygen, which might be caused by radiation from Jupiter breaking down the outer layers. It's highly dynamic, and it's making a bunch of very nerdy scientists very excited. They just want to see what's going on this little extraplanetary chemistry set. Okay, any questions on chemistry? Are you sure? You look like you have a question. Okay. Okay. Goal 3, find energy. On Earth, we cheat. We use the sun. That's where most of the energy for our ecosystems come from. I had food earlier today that was grown from plants, and that still comes from the sun. The ocean depths probably use a similar ecology that Europa does, because we're not sure how much energy it's getting from outside. So is all of its energy coming from the depths, from the tidal heating and minerals that are being produced from Europa's core, because of its 3 sister moons and Jupiter constantly trying to tug its core into oblivion with gravity? Now, if the ocean is heated by, rocky floor is heated by tidal flexing, it could be producing some very advanced nutrients. We actually discovered these in 1977 along the Galapagos Rift, an area deep in the Pacific Ocean. Everyone's seen the little tube worms. Look like creepy, something out of, like an evil tube of lipstick. I mean, what else? I mean, it looks like an evil tube or an evil tube of lipstick. I mean, so there has to be energy starting this transfer in order for an ecosystem to occur. The energy has to start somewhere. And then there has to be an organism that can capitalize on that and a slow spread down the chain. It might just all be microbial, but even if it's just microbial, it's super, super cool. Because that would mean that life has evolved independently twice in the same solar system. Yeah. Any questions about energy? Yes.
So we know, we've got ice on the surface. Do you have any idea what temperature will pop in on the surface?
It is extremely cold because there's no permanent atmosphere.
Yeah.
It gets a thin atmosphere of oxygen and then it gets blown away.
Because if there's any sort of energy exchange, you might see fluctuations in that.
There are spacecraft that are instruments, which I will be going into, that are designed to look and see if there are thermal changes in the moon's surface. Okay. Any others? Yes?
Well, how do they know which, can they tell about how much energy is coming from the gravitational pull or the gravitational and how much energy is from
Well, given the fact that it's at least 6 miles of ice, the amount of energy it's getting from the sun and also the distance is negligible at best. So most of that energy would have to be coming from the moon's interior through gravitational heating. If it is getting some from the sun, there are going to be some very surprised scientists. Because we don't even like to build spacecraft with solar panels this far out, because it's such a pain to make them big enough. Juno has 3 arms. Each solar panel in that arm, there's 3 in each arm, is taller than a 6-foot tall man. So that is a lot of solar panel for a reasonably small spacecraft, just to be able to function. And every time it goes into Jupiter's shadow, they're afraid the spacecraft's going to die. They actually have to time the orbits to avoid it, yes?
Do we know if the core of the moon is liquid or solid or whatever?
They think it does have a rocky surface underneath the ocean. Further than that, we're not entirely sure, but if it is producing volcanic activity like they suspect, there probably is some form of molten component or plate tectonics occurring. Because plate tectonics on Earth actually can't happen without the presence of water. Most people don't realize that. Yes. The wet plate goes down underneath another plate, and it's actually the plate being wet that lowers the melting temperature of the rock enough to produce magma. The magma actually isn't coming from the Earth's interior, it's literally plate melting. But they skip over that in most classes because most people are like, wait, water makes it melt? It's really counterintuitive, but that's geophysics for you. I imagine they skip it just so that students' heads don't explode. Okay. So, the spacecraft. Here, Europa Clipper is being packed up, and here are her folded solar panels. I'm glad I'm so amusing. Okay.
Did her head explode?
No, it's still intact. Her face is red, though.
Oh,
It's about to, I guarantee.
Getting
Okay, so in regards to the energy from the sun, these solar panels are 100 feet long. And it has a high gain antenna that's 10 feet long. And it has 24 little engines used for maneuvering and orbit control. All of that in the spacecraft out there. Okay, so now, does anyone have any questions before I go into the instruments?
You might be discussing this as you go through, but for the antenna, what's the turnaround time between here and there for
That will depend on where
Orbit.
it is, but
average?
hold on, I'm doing the math. Probably at least an hour round trip, if not more. Because it usually takes about 30 minutes for signals to get out there on average, I think. 30 light minutes.
Yeah.
Hey, it's better than over a day for a Voyager. I'm sorry, but I don't think I keep up a call with that bounce back. Okay, this is a wide angle and narrow angle camera. Each has an 8 megapixel sensor and will produce high resolution color and stereoscopic images of Europa. They will also study geological activity, measure surface elevations, and provide context for the other instruments. Basically, if this breaks, the rest of the mission is sunk. For water puns, since Europa. Oh, come on, y'all know I had to include at least one water joke.
Just one?
Well, I don't think it sinks the presentation.
I feel like I'm in over my head.
Just keep it in a flow.
Just wade into it.
She's gonna drown in the criticism.
Y'all trying to drown me here?
Just wave them off. Don't boil over.
Okay, so this, and as you can see, NASA in true fashion is really stretching it with the acronyms. They try, but some of them are just like, really? That's what you're going with? This is a thermal imager that will use infrared light to distinguish warmer regions on Europa where liquid water may be closer to the surface, or may have erupted onto the surface. As I said, there is some limited evidence to suggest geyser activity. It will also measure surface texture to understand the small scale properties of the surface, because they are trying to figure out how the surface is interacting with space and the ocean below. Well, if they have an infrared one, they must have an ultraviolet one. They love using these in tandem. This will actually use a telescope to collect ultraviolet light and create images that will use it to determine the composition of Europa's atmospheric gases and surface materials, which may be more than just ice. That's what they're hoping for. They will also search nearby to see if there's any sign of water flows. And I can't look at this acronym without thinking of mooses. Sorry. This is another infrared instrument, which will map the distribution of ice, salts, organics, and the warmest hotspots on Europa. They're hoping that they'll be able to understand the moon's geological history with the maps that this develops and determine if the suspected ocean is suitable for life. Any questions so far before I go through the 2 pages of instruments we have? Yes?
Europa is cold, but they consider it a hot spot.
Basically, they're considering it an area where the water is closer to the surface and where there's more heat. They are hoping that it has movement of the water like we do in the interior of our planet. And there might be hotter patches of cold currents, just like we have the Gulf Stream that keeps England from being a frozen block of ice in the winter. Any other questions? Okay. This one actually doesn't look like this in the images because this is it unfolded. It is actually an instrument that cranks out to be a vast distance from the spacecraft so that the electronics of the spacecraft itself don't interfere with the delicate electronics of this instrument. It's going to try and confirm that the ocean exists by checking the way that the magnetic field behaves around this moon. It'll also study the ionized atmosphere of Europa and determine how it interacts with Jupiter's environment. And they're also hoping to use it to measure the thickness of the ice shell and check for variances. Any questions about the ECM? Because I'm not saying all of that.
Do we know the orientation, is it the pole's top line?
Usually they assume that the pole of a planet or a moon is the same as its planet, unless it has a weird rotation. But Europa and the other Galilean moons are tidally locked, so if it's facing towards Jupiter's north pole, it's probably Europa's north pole.
Just an assumption,
We do know that a magnetic flux ring is going from Io to Europa.
Yeah.
So it would line up that the magnetic fields are probably in sync because Jupiter likes controlling everything in its vicinity. Big gravitational bully. In my personal opinion, this is the dorkiest looking of the instruments. It looks like an old, retro TV antenna. This is to study Europa's ionosphere and the plasma that is trapped in Jupiter's magnetic field. Because the magnetic field gets distorted around Europa, they're hoping to use the little Faraday cups to distinguish these distortions from the induction field that the ocean is picking up. Because Europa produces a weak induction magnetic field because of its ocean. It's nowhere near Ganymede's magnetic field, but it's still one of only 2 moons that have a magnetic field. And this might also allow us to learn more about the composition and distribution of the ocean. Anything else about PIMS? I'm sorry, I just find the acronyms amusing. At least they don't call them instrument A, B, C, D. That would get confusing very fast. Okay. This is the radio and gravity science instrument. Since Europa and its gravity field flexes the moon's non-circular orbit, carries it closer and further away from Jupiter and closer and further away to the other moons. Measuring its gravity at various points in the moon's orbit will help us show how it flexes and show more about its internal structure. Kind of like how we use seismographs to determine the composition of the Earth. Comparable to the gravity probe that Juno has, it's going to measure the changes in the gravitational field of Europa as it goes through its orbit. Because as it gets closer to and further away from Jupiter and the other moons, the amount of flex in its different parts of its structure will change. It's not a, what would this be, Europa or aquaplate, but it's about as good as we can get without setting foot on the surface, which I don't think they will let us do for a good long while because the Office of Planetary Protection is alive and well. We gotta watch out for those Earth cooties and Europa cooties if there are any. Okay, this is a reasonable acronym.
That sounds reasonable.
Yeah, I think I can get behind this acronym. Okay, so this is a radar system that is supposed to penetrate the ice sheet shell or the ocean and actually see what the structure of the ice is, how thick it is, and they're also hoping to study the elevations of the moon, its composition, its roughness, and search the atmosphere for any plumes caused by erupting water. It didn't actually say. NASA's a little vague on this point.
What's the orbital distance then we're gonna be from the surface?
The orbits are set to vary. It's going to have several tiered orbits.
Okay.
And it has two entire science campaigns. It's going to focus on the anti-Jove and sub-Jove sides because this is a tidally locked moon and they can actually orient themselves that way. So this is going to analyze the gases in the atmosphere for possible plumes, and I'll also study the composition of the suspected subsurface ocean, how the ocean and surface exchange materials, and how Jupiter's radiation belt actually alter the composition of the moon. Any questions on this one?
I think using the criteria of looking the, like you said, they dumped it into Jupiter, right?
Most missions, starting with Galileo, have had their mission objective be like their termination protocol for the mission because you have to have a way to get rid of your spacecraft once you send it up there, at least if you don't want to get busted. And basically, they were going to put Galileo in just a orbit and it would eventually decay, and they're like, there might be life on this moon. So they crashed it into Jupiter and just had it broadcast data as it went. They did the same thing for Cassini with Saturn because they discovered Titan and Enceladus might both have life. So again, kamikaze that spacecraft into the parent planet because the atmosphere is thick enough it's going to toast it anyway.
You're going to do that with a Harvard probe?
Well, I don't think you can infect the sun, but...
I'm saying they're going to crash it into the sun.
Well, whether they use the shaping object, which in this case is Venus, to dispose of it, or the sun, I don't think any of the proper solar probe is going to make it.
Well, I just want how they're going to do it.
Sometimes they'll leave the solar probes in orbit because their orbits tend to be fairly stable. But in a system this complex with 90 some odd moons, You don't want a stray moon or object sending it tumbling. Juno, when its mission is over, will also crash into Jupiter, which will not do those solar panels any favors. Okay, this is the last of the instruments. This is Suda. They are hoping that tiny meteorites will eject bits of Europa's surface into space, and that we also might be able to collect material vented from the surface into this device here, which will then be able to analyze it with its onboard laboratory.
So-
Gravity or something like that, aerogel or anything like that?
Yeah,
It's basically a little lab, and it has little partitions where it can run little experiments.
It's an opening here, it looks like it's just an opening in there, right? Down to the bottom of the.
NASA is mum as to how it functions. I was a little disappointed in doing my research. It's like, hee, we're not telling you as much about this one as we do the others.
we've identified the type of sulfur coming off of Io, right? We know what fingerprint it's got, because I'm sure it's gonna be going between them, it'll pick it up.
It's gonna be picking it up, we know that. I mean, poor Europa actually has dirt on its face from this. Okay. Now for the timeline. It has already launched, it is well on its way, hooray! And earlier this year, it had its first flyby to help shape its trajectory. And December of next year, it will be doing an Earth flyby to pick up even more speed, because it takes forever to get anywhere in the outer solar system unless you use gravity assist. Its orbital insertion will happen in 2030. The braking burn will take 6 hours to complete. That's how much speed it has picked up. But we get there in 6 years rather than a decade, so. Ganymede will be used to do the orbit shaping phase so that it is put into the proper orbital resonance with Europa for its observations. But it won't actually have its first Europa flyby until spring of 2031. And the first science campaign will focus on the anti-Jovian side. This is the side of Europa that faces permanently away from Jupiter. And this is what that side looks like. The second science campaign will focus on the sub-Jovian side. And in a weird twist, this one isn't going to crash into Jupiter. They're going to crash into Ganymede instead. I'm not even joking. We'll see how that works out for them.
Is there something they expect to get out of watching it crash? Like when they crashed the probe in the Saturn? Is it one of
They
these
just listed it as the currently planned disposal method.
Okay.
They may be trying to double up on missions. I know that there was originally a plan for them to have a bigger coordination with the Zeus mission that ESA has launched, to try and do a whole survey of the icy moons, but there were some limiting factors that required focusing of goals, i.e. not enough money. Okay, any questions? Yes?
Have they done anything yet or anything there to be able to get through the ice and examine the ocean underneath it?
This mission is purely confirming the existence of the ocean and that the materials might exist. Per the Office of Planetary Protection, that spacecraft is going to have to be sterilized to an inch of existing for us to go anywhere near that moon with a drill. Because as it is, the last standing orders the Mars rovers had, if you see water, run away. Because they aren't clean enough, they have cooties. Yes?
How accurate do they think these measurements are going to be? Are they going to be able to determine, like, without a doubt, whether or has, ocean?
Given that they have the actual tidal flex calculated with 3 meters for if it has an ocean and 1 meter if it doesn't, they must be confident of the instrument's abilities to at least read those values. And even if we just catch good details of plumes, then there's got to be water there somewhere. It may not be as much as they were hoping, but if we catch sight of a plume, there has to be water fueling that plume. It's like seeking a geyser at Yellowstone. I can't see where the water is, but there has to be water there if there's this giant plume of steam.
Do you think those features are shifting based on temperature changes and stuff like that? Like the thickness of the ice might wax and wane. So if we find a hot spot now, it may not be a hot spot later. The plume could be here. It may get covered up because of the drift, and then there's no plume.
It is an entire possibility. As far as we've observed, Europa does not seem to have a dedicated geothermal or hydrothermal area like the Tiger Stripes on Enceladus. But we only had 12 orbits to study it. And now the additional data that Juno has been collecting, because they retasked it to study some of the moons, but as always, poor Callisto was left. They did Ganymede, Europa, and Io, but we don't want any Callisto orbits. Any other questions? Oh, this mission? No.
No.
No, I never, unless it's one that's grossly over budget, I never memorize the price. Yeah. Do I get the mic too?
What's that?
I think I finished a little fast.
No, not at all.
Great.
That's okay. Very good. So, yeah, that's good stuff to know, and looking forward to 2030 when it gets there. That'll be exciting. I remember the launch of that one, so that's cool. Just a little side note on Europa stuff. I just reread for the third time or more Arthur C. Clarke 2061 Space Odyssey. That one, in case you didn't know, there are more than just 2001. 2010, he did 2061, and then 3001. Yeah, we did four. But 2061 took place out, like Europa was prominently featured in that book. They were doing all kinds of stuff. But good book.
Oh, this is a
So yeah, it'll be interesting to get out there and see what's going on. All right, to